Hi, 5.4. That's us right now. We're going to factor and solve polynomial equations. Now we have in the previous chapter factored and solved quadratic equations. Quadratic equations being a very specific set of polynomials. So we're not completely unfamiliar. It's going to be the same kind of a process. We're going to have a polynomial equal to maybe a number, okay? And then we will probably be subtracting this number over here. So we'll get this new polynomial. And we want to set it equal to 0. Remember that. Remember getting it equal to 0. And then we're going to factor it. Get the factored polynomial set equal to 0. And the beauty of that, the genius of that, if you'll remember, is that factored means multiplied together. We're going to have a couple of terms, maybe 3 terms. It doesn't really matter. What matters is that they are all multiplied together and set equal to 0. The beauty, genius, just awesomeness of this idea is that when you have it in factored form and it's set equal to 0, something times something times something equals 0, meaning that one of these has to be 0. There's just no way to multiply 3 things together and get 0 without one of them being 0. So that's the whole idea. That's what we're going to be doing in this section, and really throughout a lot of Algebra 2 and pre-calculus and calculus is factoring polynomials. Just a couple things to note. Okay, this is the biggest thing, is that we're going to factor the polynomial. Factored means it multiplied together. Okay, no adding in between these terms, only multiplying. There's a couple of special patterns in factoring that we're going to need to at least ask ourselves, oh, can we use that new pattern? That's all we really need to do. We can look up how to do it, how to factor it, but recognizing that we can use it, that's the important thing. Okay, so there's one called the sum of cubes. If you see there's this term cubed plus this other term cubed, then it can factor like this. I'm going to see if I can do it from memory. Let me just check that. Yes, I'm amazing. No, I've just done it a lot of times. Okay, so what in the world does that mean? Well, let me show you an example of 2 terms that are both cubes. Let's go with x cubed. That's clearly a cube because we're cubing it. And then 8. 8 is a cube. How is 8 a cube? 8 is a cube because 8 is 2 cubed. So now you see, as I've written it like this, it looks exactly like this. We have a cubed plus b cubed. And so we just need to fill these guys in. So a is actually x, and b is actually 2. No, it's 2. So where we see an a, we put an x. So x squared minus 2 times x, that's a times b, plus b squared. B is 2, 2 squared is 4. There you go. It is factored. You see how we took this thing that was addition, we're adding these 2 things together, and turned it into 2 things that are multiplied together. Now, if this was set equal to 0, we could set this equal to 0 and that equal to 0 and solve, and so far, you know, and there you go. None of that was English. I apologize. Next, we have a difference of cubes. A cubed minus b cubed. That will be a minus b times a squared plus ab plus b squared. Okay, what if we had 8x cubed minus 64? First, we want to recognize this as a difference of 2 cubes. This guy here is 2x cubed. Okay, so we cube 2 and x, we get 8x cubed. This is 4 cubed. And now we have it written as a difference of 2 cubes. So a is 2x, that's the first thing being cubed, and b is 4, that's the second thing being cubed, so that's how we fill in these a's and b's. So we get 2x minus 4 times, so we got a squared, so that's 2x squared plus ab, so that's 4, right? 4 times 2x, that's 8x, plus b squared, 4 squared, that's 16. Let's just fix this up just a little bit. 2x squared, 2x quantity squared is going to be 4x squared, and there we go. Okay, I've been told, I don't believe it, but I've been told that in some special cases this is factorable. Now I can't say that that's not true, but I've looked at it briefly and I just don't see a way that it could be. So I don't think this will ever be this quadratic right here that you get out of the whole thing. It's not gonna. I don't think it's gonna be factorable. And in the book and all the problems we do, for our purposes, we never get one that's factorable. So don't worry about that. If this expression were set equal to 0, and we set this equal to 0, and this set this equal to 0, and we need to solve for x here, we'd use the quadratic formula. It would be amazing. It's great that we have that. That is all, though. Just the idea that we're going to factor the polynomial, set it equal to 0, make sure that it's equal to 0, set each of the terms equal to 0, and solve. And then we have this sum of cubes, sum of 2 cubes. And then we also have a difference of 2 cubes. Okay. That's another idea that we're going to use. And we just need to recognize that it's a possibility when we're factoring. And then we'll just go back to that page that it's on and say, oh, right, that's what I need to fill in. I don't expect everybody to memorize this as I have. Before I became a math teacher, I was a math student for a long time and a math enthusiast, and I forgot this all the time. The only reason I remembered it is because I've taught this for a few years, and it just sticks in your head. There's nothing you can do about it. Anyway, let's say call it good, call her a day, and we'll get to the sample problems here as soon as you click on it. All right, thanks for watching.